Hello everybody, welcome into another lesson. So today is where the trigonometry unit's going to really start to take off. So here we have pictured the unit circle. And you see in the black ink I have the degree measure of all these angles, but next to it you probably see various multiples of pi. The multiples of pi that you see are in radians. So first we're going to start out by talking about what radians are. So radians are simply another way of measuring angles, and they're based on circles. So 180 degrees equals 1 pi radian. So you can convert from degrees to radians if you take the number of degrees times pi over 180. And you can convert back from radians to degrees by taking your pi radians times 180 degrees over pi. Basically get the pi to cancel out and you'll get a multiple times 180, you'll get your degrees. When you convert from degrees to radians, your degrees will cancel out and you'll get some multiple of pi. Now, let's do some examples here. So let's start with some very basic ones. Let's say, well, I think it's obvious 0 degrees would be, of course, you take 0 degrees times pi over 180 degrees. While your degrees are done, you would just get 0 radians. So 0 degrees is also 0 radians. Easy enough, right? Okay. Let's say I want to do 90 degrees. So I'm going to take 90 degrees and I'm going to convert that into radians. So I take 90 degrees times pi over 180 degrees. Since 1 pi corresponds to 180, well, my degrees cancel out. 90 over 180 is 1/2. So 90 degrees is the same as pi divided by 2 radians, pi over 2 radians. Let's see, then I have, let's do 180 degrees, which is a straight line, also half a circle, because a circle has 360 degrees, right? So if I take 180 degrees times pi over 180 degrees, the 180 degrees cancels out, I'll literally get pi for my radian measure. So 180 degrees is the same as pi. Now what about 270 degrees? That's 3/4 of a circle. 270 degrees, so I take 270 times pi over 180 degrees. Well, the degrees will cancel out. That would be 3 pi over 2 radians. So 270 degrees is 3 pi over 2 in terms of radians. And then let's do 360 degrees, which is a full circle. A full trip back around the circle. 360 degrees, so I'll take 360 degrees times pi over 180 degrees. I would literally get 2 pi. So a circle, a full 360 degrees is 2 pi radians. So those are some quick ones here. Now let's convert backwards. Let's say I have pi over 6 radians, right? I have pi over 6 radians, I want to convert that to degrees. So take your pi over 6 times 180 degrees over pi. Well, your pi's will cancel out. 180 divided by 6 is 30. So pi over 6 radians would be 30 degrees. Alright, now what about pi over 4 radians? So what if I did pi over 4 radians? I want to convert that to degrees. So I'll take pi over 4 times 180 degrees over pi. Well, the pi's cancel out. 180 divided by 4 is 45. So pi over 4 radians is 45 degrees in terms of that. Now, what about, we'll do one more. Let's convert one more. Let's say we have pi over 3. I want to convert pi over 3 into degrees. So pi over 3 radians, to convert that to degrees, I'll take 180 degrees, divide that by pi, multiply these, the pi's will cancel out. 180 divided by 3 is 60. So pi over 3 radians equals 60 degrees. So that's how you can convert from radians to degrees and degrees to radians real easily. It's fairly simple to do. Now, this is where you're going to have to, from this point forward, when you compute trigonometric functions of values, whether it's in radians or degrees, you're going to have to make sure your calculator's in the correct mode. Degrees for degrees, radians for radians. Now, what if I just had the value 1? That means 1 radian. Now, 1 degree is 1 degree, right? So if I see the sign of 1 degree, I'm literally going to want to make sure my calculator's in degree mode to find that. Now, if I just see the sign of 1 without the degree symbol, that means 1 radian. Radians will not always have the pi, but they for sure don't have a degree symbol. The radians never have a degree symbol. That's how you'll know if it's in radians that they want you to find. So you will sometimes find that. Now, here, of course, we're going to start going in the positive direction for angles. So, as you can see here from the unit circle, angles go up to 360, and they can actually go beyond 360 even. We'll talk about that in a minute. But up till now, we've largely worked with 180 degrees, except for when we dealt with circles, we went up to 360, of course. When we did that in geometry, we went up to 360, but we're going to have to get used to working with greater than 180 or pi radians, which you also will want to get used to radians because we're going to be using them quite a bit. And actually, as you get into calculus and some of those other courses, you'll be using radians more than degrees. So know how to convert between radians and degrees, that's for sure, so you know what you're referring to. But anyway, here you have your unit circle. Here, of course, is 0 degrees. Every angle we do, that x-axis line is going to be your initial side. Alright, so this side here is the initial side of the angle. That's where the angle starts, the initial side. It's 0 degrees. Now, let's say I want to draw a 30-degree angle. I'm going to draw it in my red ink here so you can see it. So now I have a 30-degree angle between my initial side to the pi over 6 line, which is 30 degrees. That line where the angle stops, where it goes to 30 degrees, is called the terminal side. So if you hear initial side, in this case it's with the positive x-axis, and that's what we're going to work with. The positive x-axis, that is your initial side. Your terminal side is where the angle stops. So the angle, of course, occurs between your initial side and your terminal side. So there's a 30-degree angle. Now, let's see here. You know what, for good measure, let me just draw an arrow so you can see that there's an angle between there. Now, of course, I can draw a 45-degree angle. Why don't we do that real quick? So, 45 is pi over 4. So the angle's pi over 4 radians, or 45 degrees. So my terminal side is at pi over 4. So here is my angle there for 45 degrees. We're going to go through these very carefully here so I can show you what we're looking at. And then I can draw a 60-degree angle, which would be at pi over 3. So pi over 3, there's my 60-degree angle right here from the initial side, which is on the x-axis, to my terminal side, which is at pi over 3. That's a 60-degree angle. And then, yes, I could even draw a 90-degree angle. I'll just leave that intact for the pi over 2, the 90 degrees, which will be the positive y-axis. So we start from here, go to here, that's a 90-degree angle, a right angle. So my initial side's still the positive x-axis. My terminal side is here at pi over 2, the positive y-axis. Now, let's see here. So now I can do 120 degrees, which would be 2 pi over 3 radians. So this time my initial side still, the initial side's not going to change. That's the positive x-axis, but it comes all the way into the second quadrant. So my terminal side is at 2 pi over 3, or 120 degrees. And then let's see here. Let's do 3 pi over 4, which is 135 degrees. So my terminal side now is in red at the 3 pi over 4. My initial side's still the x-axis, so here's a 135 degree angle. Now let's see, I'll do a 150 degree angle, which is 5 pi over 6 radians. Whoops, I didn't want to do that. So my terminal side this time is at 5 pi over 6. My initial side's still the positive x-axis, but there's my 150 degree angle right there. A nice big fat angle. Then of course, let's go to 180. So 180 would be pi radians. My terminal side would actually be on the negative x-axis. So there's the 180 degree angle, which is a straight angle as we remember. Now you're going to see we can have greater than 180 degrees. So let's draw a 210 degree angle, which would be at 7 pi over 6. So my terminal side's at 7 pi over 6, which is a 210 degree angle. My initial side's still on the positive x-axis. But there's my 210 degree angle, starting from here, going all the way to the 7 pi over 6. Now, we're going to do a 225 degree angle, which would be 5 pi over 4. So my terminal side is down at 5 pi over 4. My initial side's still the positive x-axis. There's my 225 degree angle. It's gotten bigger. We'll even do a 240 degree angle, which would be at 4 pi over 3. Yep, let's draw this correctly, right? So there's my 240 degree angle. My initial side is still the positive x-axis. My terminal side is at 4 pi over 3, which is 240 degrees. So there's my 240 degree angle. And then, of course, we can have a 270 degree angle. If we start from the positive x-axis, which is the initial side, to the negative y-axis, that's 270 degrees. And notice, to get positive angles, I am going counterclockwise. So when you go counterclockwise, you will end up with positive angles when you go counterclockwise. That's how it's always worked. Now let's see here. For good measure, let's do 300 degrees. So 300 degrees, that's going to be, again, my initial side's the positive x-axis, and it goes all the way around to here. So there's my 300 degree angle, which is going to be 5 pi over 3, which would give me my initial, that would give me my terminal side at 5 pi over 3. Goes all the way around to there. That's my 300 degree angle. Still going counterclockwise. Let's do a 315 degree angle. So 315 can be found right there, which would be at 7 pi over 4. That's 315 degrees. So start on the initial side of the positive x-axis, go counterclockwise until your terminal size is 7 pi over 4, which is 315 degrees. So this is a 315 degree angle. All right, let's do a 330 degree angle. So again, the initial side is going to start on the positive x-axis and go all the way to the terminal side of 11 pi over 6, which is the 330 degree angle. So from here all the way to here is 330 degrees. Then of course, let's do a 360 degree angle. How are you going to do that? You'll start, again, your initial side is the positive x-axis. You'll come all the way back around to the positive x-axis. 360 degrees is a full revolution around the circle. Now, of course, let's say hypothetically, well, we'll get into other angles in a minute, but let's talk about negative angles. So, up until now, we've also only dealt with positive angles. Well, we're going to have negative angles next. Negative angles are simply when you still start at your initial side, the positive x-axis. That hasn't changed, but you're going to go clockwise instead of counterclockwise. So if I wanted to go, let's put this in blue. Let's say I wanted negative 90 degrees. I would start at my initial side, the positive x-axis, but I would go clockwise downward 90 degrees. And notice negative 90 degrees, so this down here is negative 90 degrees. It's in the exact same position as positive 270 was, right? That's negative 90 degrees. Alright. Let's say I want to go to, let's see, negative 135. Let's say I go to negative 135. So that's going to be right here in the blue. So my initial side for the negative angle is going to be, again, positive x-axis, but going clockwise. That is my negative 135 degree angle this time, because I've gone clockwise instead of counterclockwise. And my terminal side goes clockwise instead. That's why it's a negative angle. It's not that the angle itself is truly negative, because in theory there's no such thing as a negative angle. What a negative angle really means is the direction it's going. So if it's positive, it's going the normal counterclockwise. If it's a negative angle, it's going the abnormal clockwise. So let's do one more for good measure. We'll do two more. So let's say I wanted to do negative 270. So negative 270, that's going to be my initial side, starts on the x-axis, but I go clockwise all the way around to here at negative 270. this would be negative 270 degrees, which also lines up exactly with positive 90 degrees. It's in the same position. And then, of course, I can do negative 360 degrees if I start on the positive x-axis for my initial side, go all the way back around to here, which is negative 360 degrees. That's still a full revolution around the circle, only clockwise instead of counterclockwise. That would be a negative 360 degree angle. So now we know that angles can not only be positive and greater than 180, they can be negative and less than negative 180. So they can go in both directions. And a negative angle doesn't mean the angle's negative, it just means what direction it's going in. Alright, now, let's say, lost my train of thought for a minute. Now, sometimes you may be asked, what if you were asked to find 450 degrees? 450 degrees, right? Well, what's that? That's definitely greater than 360, which is 360 is one revolution around the circle. If you have a number greater than 360, here's how you do it. You're going to subtract 360 from that number. 450 minus 360, well, that would just equal 90 degrees, right? So you're really going to be in the 90 degree position, but we are going to, you still have to go one full revolution around the circle. In this case, the angle's positive, so you'll be going counterclockwise. So you start at your initial side on the positive x-axis, go a full revolution around, and then you add 90 more degrees, and there's your terminal side at the 90 degrees. That's really 450, because it's 90 degrees past a full revolution of the circle. Now, let's say I wanted to also, we'll do one more like it. Let's say I wanted to do 540 degrees. Or no, let's do 720 degrees. So if I'm going to go 720 degrees, I'll just subtract 360 from that. So 720 minus 360 degrees, well, that would equal 360 degrees, right? That put me right back at the starting position, but this 720 degrees means this is two full revolutions around the circle. And since it's a positive 720, so you're going to start with the initial side on your positive x-axis and go counterclockwise. So there's one trip around for 360. Make your second trip around, that'll put you at 720 degrees. So that indicates two full trips around the circle, 720 degrees, going counterclockwise like normal. So we have what I just talked about are what are called coterminal angles. We just talked about coterminal angles, which is an angle plus or minus 360 degrees. That's basically a coterminal angle. If you take an angle and add or subtract 360 degrees, it's a coterminal angle because it's the equivalent measurement, only with another trip around the circle in either direction. And you got the initial and the terminal side in the exact same position. That's why it's called a coterminal angle. So let's do some examples here of finding coterminal angles. All right. So let's say we have 55 degrees. Let's find a positive coterminal angle. So a positive coterminal. And there are multiple answers for this. You can add 360 as many times as you want. Okay, but it's just best to do it once. To find a positive coterminal angle, you'll take that 55 degrees and you'll add 360 degrees to it. Which 55 plus 360, that's 415 degrees. So 55 degrees is the same as 415 degrees. You would get the same measurements there. The only difference is it's a whole nother trip around the circle for 415, right? Now, what if we were asked to find a negative coterminal angle? So, a negative coterminal angle, well, okay. So this time we would take that 55, we would subtract 360 from it because we're going to go in the clockwise direction for once, but it's still going to put us in the same initial and terminal positions. So 55 minus 360 degrees, well, that would put us at negative 305 degrees, right? So the coterminal negative angle of 55 degrees would be at negative 305 degrees if you were going clockwise. But you would be in the same, your angle would have the same terminal side. It'd have the same initial and terminal side. The only difference is which direction of the circle are you going. That's all that's referring to. Alright, we got more. Now, let's say I have 210 degrees. So I want to find a positive coterminal angle for 210 degrees. So take that 210 degrees, add 360 to it. So we're going to go another positive revolution around the circle, which is counterclockwise. Well, this would give you 570 degrees. So 570 degrees is one of many positive coterminal angles. If you wanted to, you could add yet a whole nother 360 and get an even bigger number, which would put you at 830 degrees if you really wanted to do that, but you don't have to. So 570 degrees is a positive coterminal angle of 210. It's just another trip around the circle. Now, if I have to find a negative coterminal angle, let's take 210 degrees minus 360 degrees. Well, that would give me negative 150, right? Negative 150 degrees is a negative coterminal angle because I went a revolution around the circle backwards in clockwise position instead of counterclockwise. So negative 150 is a negative coterminal angle to 210. All right, let's see here. Now, how about 420 degrees? So 420 degrees, right? I still want to find a positive coterminal angle. Well, here's the thing about this. We have a couple options here. We can add 360 and get 780 degrees, or we can still subtract 360 and still have a positive coterminal angle because 420 is greater than 360, right? If the angle is already greater than 360, you can subtract 360 and get a positive coterminal angle. So 420 minus 360 degrees, well, that would just simply be 60 degrees. So a positive coterminal angle for 420 would be positive 60. Now, what if I want to find a negative coterminal angle? Well, I can take my 420 and then twice over subtract 360, or I can just take my 60 and subtract another 360. So if I take my 60 degrees, subtract another 360 degrees, I would get a negative 300 degree coterminal angle. So a negative coterminal angle for 420 degrees would be negative 300 degrees. Alright, let's get wild with the next one. What if I had a 544 degree angle? So I have a 544 degree angle. Well, it's greater than 360, so I can still subtract 360 and be in the positives for coterminal. It's 544, however, not just 540. So 544 degrees minus 360 degrees, that would give me a 184 degree angle. So a positive coterminal angle for 544 is positive 184 degrees. It's just one trip through the circle clockwise instead of counterclockwise. Now to find a negative coterminal, I can take that 184, subtract another 360 degrees, and you'll get negative 176 degrees. So negative 176 is yet another, that's a negative coterminal angle with 544. You get negative 176. Alright, now we're going to switch to radians. I have 4 examples I'd like to do with radians. So, because we got to get used to radians. So, what if, for example, we were given 13 pi over 2 radians? So, 13 pi over 2. Well, what's a full circle? That's 2 pi radians, right? And I can tell you 13 pi over 2 is well over 2 pi. You just need 4 pi over 2 to be over 2 pi. So let's find a positive coterminal. If I take 13 pi over 2 minus 2 pi, what would that give me? Well, 2 pi is the same as 4 pi over 2. That would give me 9 pi over 2. Which is another grand possibility you could get. You can get 9 pi over 2. That would be an acceptable answer. But let's build from 9 pi over 2. I'd like to get it down below 2 pi. 9 pi over 2 minus another 2 pi. Well, that's another 4 pi over 2 down, so that would give you 5 pi over 2. That's another possibility of a coterminal angle is 5 pi over 2. But, again, I would like to get it under 2 pi, if at all possible. And 2 pi is the equivalent of 360. That's just in radian form. So, let's take 5 pi over 2 minus 2 pi. Well, that's the same as 5 pi over 2 minus 4 pi over 2. That would just give me pi over 2. So, pi over 2 is definitely a positive coterminal angle, right? Now, to find a negative coterminal angle, I could just take pi over 2 and subtract 2 pi from that, right? So that'd be pi over 2 minus 4 pi over 2. That's the exact same as negative 3 pi over 2. That would give me a negative coterminal angle for 13 pi over 2. Because 2 pi revolutions in either direction is a full trip around the circle. Alright. So some of these will have multiple answers. Now what if I have 17 pi over 4? So I've been given 17 pi over 4 radians, okay? Well, that's clearly over 2 pi still, right? because 2 pi would be 8 pi over 4. So let's find a positive coterminal angle by taking 17 pi over 4 and subtracting 2 pi, which we know is the same as 8 pi over 4. That gives you 9 pi over 4. So 9 pi over 4 is one possible answer, but it's still over 2 pi. I would like, again, if at all possible, to have it less than 2 pi. So let's take that 9 pi over 4 that we just got, subtract another 2 pi. So 9 pi over 4 minus 8 pi over 4, that gives you pi over 4. So pi over 4 is a positive coterminal angle for 17 pi over 4. Now, to find a negative coterminal angle, I could take that pi over 4 and then subtract 2 pi. So pi over 4 minus 8 pi over 4, that's negative 7 pi over 4. That would be the negative coterminal angle for 17 pi over 4 would be negative 7 pi over 4. I have 2 more radian ones, then we're done. All right. I have 24 pi over 7. So I have 24 pi over 7 radians. Well, clearly, again, it's over 2 pi, right? Because 2 pi would be 14 pi over 7. So let's find a positive coterminal angle by subtracting 2 pi from this. So 24 pi over 7 minus 2 pi, which would be minus 14 pi over 7, that would give me 10 pi over 7. So 10 pi over 7 is definitely a viable positive coterminal angle for this. Now, if I want to find a negative coterminal angle, let's take that 10 pi over 7, subtract another 2 pi. So 10 pi over 7 minus 14 pi over 7, that would give me negative 4 pi over 7. So negative 4 pi over 7 is also very much a viable negative coterminal angle. And I got one more, then we're done with the lesson. Now, let's make it easy. Let's do 2 pi over 3. So I have 2 pi over 3 radians, right? I'm going to find a positive coterminal angle. Let's add 360. So if I take 2 pi over 3 and I add 2 pi to that to get a positive coterminal angle, well, 2 pi is the same as 6 pi over 3. That would give me 8 pi over 3. So 8 pi over 3 is one possible viable positive coterminal angle. Now, to find a negative coterminal angle, take that same 2 pi over 3 and subtract 2 pi. Alright, well, 2 pi is 6 pi over 3, so 2 pi over 3 minus 6 pi over 3 equals negative 4 pi over 3. So negative 4 pi over 3 is very much another possible answer for a negative coterminal angle. So that's it for angles, the general unit circle, converting degrees to radians, radians to degrees, and the type, the initial side, terminal side, and finding coterminal angles. Next lesson, we're going to get into arc length and area of sectors of a circle, which are heavily going to apply radians, and how to, if you're given a degree, you'll actually have to convert it to radians in order for this formula to work. So I hope everyone has a great day. Take care.